So hello everyone, and today we'll be seeing one of the problem from Leetcode. The problem says number of smooth descents period of the stock. The problem goes like we are given an integer array prices representing the daily price history of a stock, where the price of I is the stock price on ith day. Okay, cool. Now what does smooth descent means? So smooth descent period of a stock consists of one or more continuous days such that the prices on each day is lower than the price on a preceding day by exactly one. So the first day of the period is exempted from this rule. Okay, because we don't have anything prior to the first day, so we exempt the first day. Return the number of smooth descent periods. So there are two conditions. It should be the next coming price should be lower, and the next coming price should be lower by exactly one. So that's true. Let's take this hypothesis, apply this on this example, and let's see where does it go. So we have this array. Obviously, so within this array, how many decent we can get is one thing, that we have an individual individual day. So within each individual day, we count this as an descent period, and this period would be of length 1. So because it consists of one or more contiguous days, so even one day is as well calculated, so we allow this one day as well. So I'm taking every day, and that has been taken here as well. Then I'm taking 3-2, which is valid, 2-1, which is valid, and 2-3-2-1, which is also valid. Cool. That helps. Now same thing applies on the example 2, but here we get only 4, because as you see there is no decent decent smooth descent period, because the difference between 8 and 6 is 2. We don't want 2, we just want exactly 1. Same as with a single element, and we are given few constraints. One thing which can strike your mind immediately is that, hey, we can have a way in a way we can have a structure in a way that why don't just you go ahead and consider each of the things. So from I to j, consider that is it decent or not, and is it decent, what do you say, is it in the period or not. That's what I'll say. And if it is, then increase the count. Okay, that works, but that will cost us around O of n square. So can you do better than that? And the answer comes out, yeah, maybe, but we need to understand the pattern. One thing which holds true to this solution is the period is continuous. So in this example, we were going from, let's take this example, and we are going from 3 to 2, whereas we take I from 3 and j incrementing from this. Next time we take I from 2, j incrementing from this and this. But wait a second, j has already traversed 2, 1 and 4. So why we are required to iterate I? Because we already know that, hey, j would go from 2 to 1 to 4, and we already know 2 and 1 are within, within a period. So if I'm coming again to 2 and asking 2 and 1, it would be a repetitive task. So how can I understand this? So let's break it down bit by bit. First of all, do I know currently, am I in period or not? That's the first question. That's the first question we should ask, and I guess the answer is pretty simple with that. The answer should be yes or no, with the respect of fact whether my previous is minus the current of I is equal to 1 or not. If this is true, then yes I am, else no I am not. Cool. So we have understanding of our neighborhood, and we can iterate one by one. So with 3214, can I understand that hey, I am in the loop or not, or I am within the pattern or not? So I'll mark plus if this is within the period, else I'll mark minus. So this is within period, this is within period, and this is not within period. So cool, we have all these three. And when I'm saying this is within the period, I am saying it is within the continuous period. Obviously, if you take 4 individually, it is within the period itself. But we are not considering this because we want a continuous thing. And that's where the problem lies, because we don't want it to reiterate the continuous things. 2, 1, remember? With this in mind, how can we solve this? So we have 3, we went to 2, we went to 1. What kind of results do we found out? So in case of 3, the count was 1. When we came to 2, the count was, okay, again, if I'm talking about 1, I would also say it is just 3. Now the count would be 2. Why? Because, no, not 2, but it would be 3, right? Yes. Why? Because 3, we have 2, we have 3, 2. Okay, I'll take this as semicolon. We have 3, 2 in this way. So that means we have plus 2 here. Then we have count as, what would be the count here? 6, I guess. Or wait a second, we'll calculate the count. We have all these things from previous. Let's not rewrite it. But now we have one extra thing, which is 1. Now we have extra thing 2, 1. Now we have extra thing 3, 2, 1. Correct? So this is plus 3. I guess you are understanding the pattern over here. So this plus 3 to this 3, which is 6. And the pattern here is nothing much that a new number which is within the continuous period would contribute to rest all continuous period elements. So if my continuous period was 1 and the next element was 2, second element, then I would calculate contribute to rest of the elements as well. So second element, so I'll just add a 2. Now we have count as 3, continuous as we have, let's take this example 3, 2, and we have 1. So we have 3, 2. Now I see 1. What to do? So see, now I see 1. The continuous, or I'll say continuous period CP was initially 2. Now I see CP plus plus, which would be 3. So now the count would be increased by CP. Updated value of CP is 3, so plus 3. Why? Because the continuous period would become 3, and this incoming element, which is 1, would be responsible to take 3 new elements by its side. So if I'm taking, if you can visualize this very well, then I have only 3, then comes 2, then I'll become 3, 2, and 3, 2. Okay, so this is end of 2. I've considered 2. Now if I'm taking 1, I'm taking 1, 2, 1, 3, 2, 1, end of 1. and I'll take 1. Similarly, take 2. So doing this, you would visualize this much more. Initially only one element, which is 3, from the array 3 to 1. We take 2 and we can say that, hey, I can take individually 2 as individual number, or I can take 2 with the previous continuous stream or continuous period. So that is the thing. When we track down the continuous period, and if the continuous period increases and the new number kicks in, we can say that, hey, continuous period plus 1. So continuous period here was 2, here 1 takes in, so 2 plus 1 is 3, and that's why we are adding 3. Now with this logic, we are pretty much clear, and don't you worry about the code. Code is very, very simple. So we have long count 0. They are expecting long. Maybe the count would be very big in number. So long continuous period, which is initially 1, and count is 1. Why we are taking 1? Again, because we are taking our counts from index 1 and not 0. And I is less than prices dot length. Again, why we are taking it from 1? Because we wanted to check the previous element, prices of I minus 1. If we took it from 0th index, it would be minus 1, which is not what we wanted. So I minus 1 minus prices of I is equal to 1, then only it is in the period, else not in period. So if it's in the period, I will increment the continuous period plus plus. If it is not in the period, I will reset the period to 1. And now we know that it is a period. I need to include this within the count, and as we see that each period is responsible itself for its own count. So it is period with a length 3, so 3 would be added, because you see 3 lines, right? If it is a period of 2 lines would be added, and count plus 2, and so on. So count plus CP, that is the only thing. And yeah, so far so good. Ultimately we'll return the count and we are done. Let's run this code for any sample compiler errors or any of the sample test cases. Yeah, it is working fine. I'll submit it quickly with zooming it out. And yeah, it has passed all the test cases, and it beats 100% of the code, because there was not much within the code itself. It was just a simple if else, but a huge understanding of how continuous progression increments your count, and that's it. So that is all about it. It was a part of a dynamic programming. I don't know where we touched this dynamic programming, but in near future we will be considering more of the dynamic programming videos. If I do have any dynamic programming videos, click the video on your right, and maybe I'll see you in the next one.